Okay, so as we read this first problem, you have a 100 Newton block that sits on a rough horizontal floor. Horizontal is good because that means we don't have to break any vector components. Rough indicates this coefficient of sliding friction, also known as kinetic friction, between the block and the floor. It's 0.250, remember that's unitless. Horizontal force of 90 newtons acts on the block for 3 seconds. So time might be a little bit new to you, but it shouldn't be because we're dealing with acceleration from a force as well. And so this is pretty easy using our old kinematics formula to figure out its velocity from rest at the end. Final velocity is what that is. But we have to do a number of steps to get there. I started by writing pretty much what we knew in white. I drew my free body diagram here. Applied force, I made it positive to the right, 90. I went ahead and turned this 100 Newton block. That was used to indicate a weight. And I'd like to know that the force of gravity is causing that, but we're going to need that later on. So I just made it the normal force because it would be positive. And if it's horizontal, it is going to be in the upward direction and positive. I know we're going to have friction because we have the coefficient of friction. Like I said, we're going to need to know that gravitational force so that we can get the mass of the block. Really, you can go ahead and start there. So that force of gravity is equal to mass times acceleration due to gravity. We know this equals 100 newtons. So resolve this equation for mass, and you get force of gravity divided by acceleration due to gravity equals mass. Plug in those numbers. You get that it's 10.2 kilograms. I now have its mass. I want to know the frictional force. Well, I have the normal force, I have the coefficient of friction. That's all that a frictional force is normal force multiplied by the coefficient of friction. Plug in my values. I get that the frictional force is 25 newtons. I then need to come up with the sum, or the net forces. So my net force is just the sum of all forces acting on it. Well, we already know that the normal and gravity cancel each other out, so I'm just going to look in the x direction, and so I have the applied force minus the frictional force. 90 newtons minus 25 gives me 65 newtons as a net force. With that, though, I now know its mass, I know its net force, and I know my other formula for net force is that the mass times acceleration equals the net force. So I can use this to solve for what my acceleration would be. My net force is 65 newtons. My total mass is 10.2 kilograms. Gives me an acceleration of 6.37 meters per second squared. Now that I have an acceleration and I have a time, then, and also I know my initial velocity is 0 because it's starting at 0, I can use this kinematics formula. So final velocity is equal to initial velocity plus acceleration times time. However, initial velocity is 0. I don't have to worry about that, and I just have to multiply my acceleration times my time. Plug those numbers in. You should get 19.11 meters per second for your final velocity. Okay, so for number 2, force of 160 newtons parallel to an inclined plane, so we are dealing with a tilted plane this time, is required to move a 200 Newton weight up the inclined plane. So we're moving up against gravity with a constant velocity. Woohoo! Constant velocity. That means no acceleration, or our net force will equal 0. Find the coefficient of friction, of sliding friction or kinetic friction, if the plane is inclined at 30 degrees. So I went ahead and I put in our 30-degree angle here. I put our mass, and that it's currently moving up with a force of 160. We know its weight, or its force of gravity, that's pointing straight down, is 200 newtons. At that particular time, I needed to tilt my axis. So I need to say, this is now my axis. That's my y, that's my x. We'll indicate that those are positives in those directions. And then I can break things down into my component parts, as I have before using my trig. Now, that's enough to give me all of the different parts that I need for that. I know that I'm going to have a normal force. I know that I'm going to have a frictional force. That frictional force is the first thing I need to pay attention to. I need to because it's where my coefficient of friction is, and that's where I would be looking. So I take my formula for friction, which is just normal force times coefficient of friction, and I solve it for the coefficient of friction. So friction divided by the normal force will give me the coefficient of friction. But I don't have these things yet. First thing I'm going to find is my normal force. That's easy enough because all it is going to be equal in magnitude but opposite in direction to the part of my force of gravity, the part of gravity that's pulling it perpendicular into the ramp. I get that by doing force of gravity times cosine of theta. We already know that gravity is 200 newtons. The angle is 30, so theta was 30. So if you put that in your calculator, you should get that the normal force is 173.2 newtons. A little bit harder to get is our friction. Now we can, simply because that friction is also a part of our net force. We know that our net force is going to be equal to our positive force here, our force of applied force, minus both frictional force and the part of gravity that's pulling it down the ramp. So you have our applied force, part of gravity pulling it down, and the frictional force. But we know all of those together are going to equal 0 newtons. So we can start to solve this for that frictional force. Now we have our applied force minus the force of gravity downward has to equal that frictional force. Well, we know that frictional force, or the amount going down due to gravity, is just the force of gravity times sine of theta. And we know that the applied force is 160. So we can plug all of those values in like I did down here. And we would get that the frictional force has to be 60 newtons. Okay? Now, don't worry so much about the negative and positive for something like this, simply because it's going to make it a ratio. And a ratio, we're not worried about units. We're not worried about positive or negative, because it would only be positive. It doesn't have a direction. That coefficient doesn't. So what we're going to do is we're going to come up here and we're going to plug each of those things in now. So now I have this. I know that I have 60 newtons divided by 173.2 newtons. And that's rounded slightly, but it's okay. And if I look at my calculator, I'm just going to round this to 3 decimal places. And so I'm going to get, and I'll try to write it down here, 0.346. And that's what my coefficient of friction is. And so that would be my answer.